notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 to 2027, or unless revised. Schedule of videos. These first 3 sections here, 1, 2, 3. All 51 of those videos have been published in their entirety on YouTube. Section 4, measurement. All 17 of these videos have been completed. 5 have been published in their entirety on YouTube. Section 5, statistics. 18 videos from that section, all completed. 5 have been published in their entirety on YouTube. We are now at section 6, algebra. This is the 22nd of 22 videos, and today is the last day in September 2025, so at least this schedule is on track. Section 7, relations, functions, and graphs. By October, end of October 2025, should have that completed. Section 8, geometry and trigonometry, by November 2025. And finally, section 9, vectors and matrices, by the end of December 2025, the end of this year. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. Section 1, number theory and computation. I have divided section 1 into 33 videos, all of which are available on YouTube in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So please make sure you look at these 33 videos and know them very well. If not, you may have problem with the rest of the objectives in the rest of the syllabus. Reminder, you need to know the times tables from 2 to 12. If you don't already know them, you would have to learn them, especially since calculators are not, I repeat, not allowed in paper 1. From section 2, consumer arithmetic, there are 12 videos in this section, and all of them have been published on YouTube in their entirety. Section 3, sets, there are only 6 videos in this section, and all of them have been published in their entirety. Section 4, measurement, there are 17 videos in this section, and these 5 that you see indicated in yellow here have been published on YouTube in their entirety. The others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 5, statistics, there are 18 videos in this section, and these indicated in yellow here have been published on YouTube in their entirety. These others are only partially published on YouTube. Please see directions in the description below for full access to these videos that are only partially published on YouTube. So section 6, algebra, this section has 22 videos. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends the following shown at right, these here. From those, please pay close attention to these last 2 down here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current CSEC math examination. This is a picture of volume 1, Mathematics, a Complete Course, with CXC questions by Raymond Tulsi. And this over here is a picture of volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, very recently, late 2024, I think, a website with AI interactivity has been made available free of cost that deals with past CSEC math questions only, specifically from paper 2. You can navigate that website by topics or years, where all questions for the past several years have been worked out. If you still have a question that you need explained, you can ask the AI assistant either by text or voice, and most likely that will be explained. It is extremely important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. On the next slide, I will show you what the home page looks like, which is this that you see here. You will first have to register and then sign in. Again, this is the URL up here. This URL will be included in the description of this video, so you can easily click on it and be redirected to this website. This is a reminder that for these CXC math examination papers, you will be provided with a formula sheet as shown on the left here. There will be a link in the description below from where this formula sheet can be downloaded. Of course, if you have a copy of the full syllabus, that formula sheet is included in the syllabus. This is the top part of that formula sheet, so you could see some of the things a little closer. Please note, you do not need to learn these formulae on this formula sheet, as this sheet will be provided during the examination, as I just said. And this is the below part of that same formula sheet. While you do not need to memorize these formulae, you do need to know when and how to use them. Overview of Algebra, Section 6. I will move quickly here. We already completed Objectives 1 to 4, as pointed out before. Then we completed 5 to 7, everything here. And on the next page, everything here, 8 to 11, completed. And on the next page, everything here, 12 to 16. Finally, we are at this page where we have completed up to Objective 20. So 17 to 20. This now is the last objective, and it's mainly a review of what we did in Objective 20, which we will do in video 22. So as I said, we got through 21 videos, which took us to Objective 20. Out of those 21 videos, these 6, as indicated in yellow here, have been published on YouTube in their entirety. The others are only partially published. After all that hard work, it might interest you to know that this last objective involves easy work you did maybe in grades 3 and 4 in primary school. But we will look at them from a slightly different angle. I am now at Objective 21, which is video 22. Once this video is finished, it will be published in its entirety. So as I said, we are here, Objective 21, which says, solve problems involving direct variation and inverse variation. And that will bring us to the end of Section 6, Algebra. Now, the good news is that we already covered Objective 21 when we did Objective 20, basically. So, We will quickly review those examples and a few others in this objective. Before we continue, we need to review three concepts that we looked at in the last video. First one is this one here, direct linear variation, where y varies directly with x, and so y is equal to kx. We will look at a few of those that we already looked at. Then this next one on the right here, which shows inverse exponential, where y varies inversely with x, or y is equal to k over x. Now, those are the only two formulae that you were given in the syllabus in the last objective. But as we saw, there was a little problem, and we didn't get a formula for this one. Well, it is also y varies inversely with x, except it is not this one over here. So to work out questions like this, we actually need to consider k as negative. K, of course, is the gradient. So over here on the left, direct the gradient is positive. This one in the middle here, it's negative k. And we will look again at two such questions that we already considered in the last video. So let's deal with direct. We will not make use of this format, but if you see it, you know how to use it. The truth of the matter is we have been using it transparently without knowing, even in grade 3. So instead, we will use math from your primary school days. Example 1. The wage of an hourly worker was $57 when he worked 6 hours. Calculate his wage if he were to work 8 hours. Well, obviously, it will be more. So we have a direct relationship. So begin with the unit mentioned twice in this question. As you could see, hours are mentioned twice. But we will not begin with this 8 hours because we have nothing to go with it. So we will begin with the 6 hours because we know the wage there is $57. So we begin. In 6 hours, he earned $57. So for 1 hour, he will earn 57 divided by 6, which is $9.50. But you don't need to work that out since we put back that expression down here. Therefore, in 8 hours, he will earn this amount, multiply by 8, which gives us $76. Incidentally, that $9.50 is actually that K up there. We never learned it that way, but be aware that that $9.50 is actually K, the constant. So our answer is $76 using the primary school method. Now, alternatively, this can be solved when set up as ratio and proportion. For direct variation, set up like quantities as numerators and match the denominators. So 6 hours is to $57 as 8 hours is to how many dollars? Notice this 6 and this 8 will appear as numerators. So you get 6 over 57 is equal to 8 over x. You could turn this around, it doesn't really matter. The hours could be as denominators. And then you match the 6 with the 57. So if you cross multiply, you get 6 hours times x is equal to 57 times 8. Divide both sides by 6. And so you get the same $76. So you can do it that way, if you like. But do it the easiest way, unless you are told to do it another way. If you find this video useful and interesting, please like and share. That is, like and share. You may also consider subscribing to this channel. Question 2. The cost of printing 100 pages is $25. What will be the cost of printing 175 pages? Assume same rate. So as I said, we will not make use of this format on the left here. Though of course we are, but we are using it transparently. But if you see that format, you know how to use it. Instead, we will use math from your primary school days where you were actually using that format without knowing it. We will begin with unit mentioned twice in this question. Notice pages are mentioned here and pages are mentioned here. But we will not begin with 175 because that is what we want to find. But you know 100 pages cost $25. So we begin there. 100 pages cost $25. Then one page will cost 25 divided by 100 will be less, which is actually 25 cents. No need to work that out since we are using this whole expression down here. So 175 pages will cost that amount. Multiply by 175 and you get 43.75. Now this 25 cents here was actually that K up there. But as I said, you weren't told that in primary school. And even in secondary school, you may not be told that unless you recognize it here. So $43.75 more page costs more. That's direct variation. Alternatively, this can be solved when set up as ratio and proportion. For direct variation, set up like quantities as numerators, or both of them could be denominators, and match the denominators. So what we have is 100 pages is to $25 as 175 pages is to what? When you set that up as fractions, you get 100 pages over 25. You know this is equal to 175 over x. Notice pages are both numerators. You could set them up as both denominators as well, but do not cross them over. And so when you cross multiply that, you get 100p times x is equal to 25 times 175. You divide both sides by 100, and you get x is equal to 25 times 175 divided by 100. And your answer is 43.75, which is the same answer we got up here, using the old time method you learned way back in grade 3. All right, example 3. As I said, we will not make use of this format, though indirectly you are using it without knowing about it. You actually found that K. So instead, we will use math from your primary school days. We will begin with the unit mentioned twice in the question. As you could see, 8 notebooks, 5 notebooks. Well, this 8 notebooks is what we have to find the cost. But we know 5 notebooks cost $15. So we will begin there. 5 notebooks cost $15. Then 1 notebook will cost 15 divided by 5, which is $3. Reminder again, that $3 is actually this K up here. So 8 notebooks will cost what 1 notebook costs times 8, which is $24. That's doing it the grade 3 way, $24. Now this time, we are not going to use ratio and proportion. We are actually going to use that. Well, okay. If you really want to use this formula, y is equal to kx, let me show you how it can be used, though you actually use it there without realizing it. Y is the quantity given once, so that would be $15. And x is the amount related to that given y, which will be 5. So what do we do with that? We will find k. K is equal to y over x. Now remember what we said y is and what x is. So k is 15 divided by 5, which is $3 per notebook. Remember this up here. That is k. Now that you find that, you will go back to this equation here. You want to find y. You know what x is and you know what k is. So we want to find y. We know what k is and we know what x is because x is now the other quantity given here that is not related to anything, which is 8 notebooks. So y is equal to k times x. You multiply that and you get $24. Okay, that may sound confusing. If you don't have to use it, don't use it. Use the simple method that you learned in grade 3 in primary school. So let's do example 4. A car travels 270 kilometers in 3 hours. How far will it travel in 7 hours? Assume constant rate throughout. Well, I told you we will not make use of this format in this objective, but if you see it, you will know how to use it. We will look at that after we look at the simple method. We will use math from primary school days. Begin with the unit mentioned twice, which would be hours, right? But you will not begin with this 7 hours because there is nothing related to it. You will begin with this 3 hours because there is something related to it. So you say in 3 hours, car travels 270 kilometers. Then in 1 hour, it will travel 270 divided by 3, which is 90 kilometers. And in a little while, you will see that that 90 is actually this k here. And so in 7 hours, it will be that 90 times 7, and you get 630 kilometers. So our answer is 630 kilometers. Okay, so let's actually use this formula and see how it works. Y is the quantity given once. X is the amount related to that given y. We will use that to begin with to find what k is, and then we will go back in this equation and find y now that we know k and we know x. X is the other amount given. So k is equal to 270 divided by 3, which is equal to 90. Notice this 90 here using the old-time method. So y is equal to kx. Now we want to find y. We know k is 90 and we know x is the other quantity given. So y is equal to 90 kilometers per hour times 7 hours, and you get 630 kilometers, which is what we got using the grade 3 system. All right, we will do one more here. It takes 5 days for a farmer to plow a field 2 hectares. How many days will it take him to plow a field of 7 hectares? So let's use the old-time primary school math. I will not do this using that, neither will I use it using ratio and proportion. You could do that for yourself. So we begin with the unit mentioned twice, which would be hectares. But this 7 hectares is what we want to find the time for. So nothing is related to that in this question. Now, what is related to this 2 hectares would be those 5 days. So farmer plows 2 hectares in 5 days. Then 1 hectare will take 5 over 2 days, which is 2.5. Recall, that is actually k up here. And so 7 hectares will be this 2.5 multiplied by 7, which gives you 17.5 days. 17.5 days, which is reasonable. Larger field, more time. Now you can verify this answer using ratio and proportion and or this formula. I'm not doing that for you. And those will suffice for direct variation. Now let's look at inverse variation, where y varies inversely with x, or y is equal to k over x. So we will not make use of that format given in this objective. But if you see it, you will know how to use it. Of course, we will look at it later on briefly. Instead, we will use math from primary school days. Example 6. If 2 men can build a house in 100 days, how long will it take 8 men working at the same rate to build the same house? So we will begin with the unit mentioned twice in the question, which is men. But we will not deal with these 8 men because we want to find how long they will take. But we know 2 men will take 100 days. So we'll begin with that. 2 men take 100 days. Now, 1 man, will he take more days or less days? He will take more days. So you multiply the 100 by 2, not divide. So now we have inverse variation, and we get 200 here. Now, if you were working that out, that k would actually work out to be 200. But you don't need to work it out because we are using this whole expression down here. Or you could just put 200 there. Doesn't really matter. Therefore, 8 men will take 100 times 2, which is 200, divide by 8, which gives us 25 days, which is reasonable. More men will take less time. So we get 25 days. Now, we can work this out also using ratio and proportion, but you have to be a little more careful because this is not direct. This is inverse, and inverse exponential at that. So for inverse variation, set up like quantities as fractions, not as numerators, but as fractions, and switch the second given quantity around. Let me explain that. 2 men and 8 men. So 2 men is to 8 men as x days is to 100 days. So when we set that up as fractions, we get 2 men over 8 equal to x over 100. Notice those 2 men took 100 days. Notice 100 is not up here. 100 is down here because it's inverse variation. So now that we have that, we cross multiply and we get 2 men times 100 days is equal to x times 8 men. Flip the formula around and divide both sides by 8. And so you get x is equal to 2 men times 100 days divided by 8 men. 2 men times 100 days divided by 8 men. And that gives us the same 25 days as we got when we saw that using primary school math. So you don't have to use ratio and proportion unless you are told. If you see a math question, use the simplest method you know, provided you know each step is valid. Example 7. If a car traveling at 30 meters per second takes 40 minutes to complete its journey, how long will it take if its velocity is 50 meters per second? As I said, we will not exactly be using this formula here, though we are without knowing it. Instead, we will use math from your primary school days. So we begin with the unit mentioned twice in the question, and that would be meters per second, meters per second. We will not begin with this 50 meters a second. That's what we want to find how long it will take. We will begin with this 30 meters per second because we know that took 40 minutes. So we begin. At 30 meters per second, it takes 40 minutes. At 1 meter per second, which is very slow, it will take much longer time, which is 40 times 30, which will be 1200 minutes. As I said, we don't need to work this out since we are actually putting that back in the question. So at 50 meters per second, it will take that 1200 there, which is this, divide by 50, which would be 24 minutes, which is reasonable. It's traveling faster. Therefore, it will take less than the 40 minutes. It takes 24 minutes. That's using grade 3 math from primary school. Alternatively, this can be solved when set up as ratio and proportion, but remember this is inverse, not direct. For inverse variation, set up like quantities as fractions and switch the second given quantity around. So 30 meters per second is to 50 meters per second as x minute, that's what you want to find, is to 40 minutes. You can see that better when we look at it as fractions. 30 meters per second over 50 meters per second. That's this two side of the proportion. And then this other side here is x minute over 40. Notice this 40 here is related to that 30. So we actually switch it around. We didn't put it up here, but rather down here. Now, when we cross multiply that, we get 30 meters per second times 40 minutes is equal to x times 50 meters per second. Flip this equation around and divide both sides by 50 meters per second. And so you get x is equal to 30 meters per second times 40 minutes, divide by 50 meters per second. And what do we get? We get 24 minutes, which is the same answer we got up here using grade 3 primary school mathematics. So example 8, a fixed mass of gas occupies a volume of 400 cubic centimeters at a pressure of 5 kilopascals. Calculate its volume if the pressure is increased to 8 kilopascals. You don't need to know this except that it is inverse. If you increase the pressure, the volume will decrease. You don't need to know about that nor what we mean by kilopascal. So we will actually look at that after we consider the primary school method. Let's begin with the unit mentioned twice in this question, which is kilopascal. But we will not use this kilopascal since we want to find out the volume for that. We will use this kilopascal since we know what volume is there. So we say at 5 kilopascal, its volume is 400 cubic centimeter. So at 1 kilopascal, which is much less, its volume will be much greater. So we multiply by 5, not divide, which gives us 2,000. And in a little while, we will find out that that 2,000 is really K, if you use this formula. Therefore, at 8 kilopascal, its volume will be that 2,000 divided by 8, which gives us 250 cubic centimeters. So you increase the pressure, the volume decreases. Inverse variation. So we get 250 cubic centimeters. So let's actually use this formula, though we said we wouldn't be using it. Let's use it. Y is the quantity given once. X is the amount related to the given Y. So first of all, we'll flip this equation around. We'll find K. So K is equal to Y X. K is equal to 2,000 cubic centimeters. Remember this from the primary school days, from the primary school method. Now, since we know K and we know X, which is this, we want to find Y. So Y is equal to 2,000, that is K, divided by X. And so we get Y is equal to 250 cubic centimeters, which is what we got here using the primary school grade 3 method. Now, this format here will not work because we are now looking at linear inverse variation, linear, not exponential. Your phone battery is 100% charged at 7 a.m. and only 2.5% charge remains at 8 p.m. If the battery discharge is linear, that means it's constant, what percentage charge will it have at 1 p.m.? Since its discharge is linear, we need to first find its discharge rate. So what we will do, we will divide the 97.5%, that's the difference between 100 and 2.5, divide that by 13 hours and we get 7.5% per hour. So Charge used over 13 hours is 97.5%. Therefore, in 1 hour, its rate of discharge would be that 97.5% divided by 13 hours, which would be 7.5%. So we find, first of all, the rate of discharge. In 6 hours, that is at 1 p.m., that's from 7, so 6 hours later, so 7 a.m., it is 100% charge. 6 hours later, which is at 1 p.m., which is what we are asked to find, its total discharge would be 7.5 times 6, which would be 45%. Therefore, the charge remaining at 1 p.m. will be 100% minus 45%, which is equal to 55%. It is not as difficult as you may have thought it was, but we can't use that formula or inverse proportion because that formula applies to inverse exponential. So 55%. And finally, example 10, you are leaving the supermarket. As I said, you saw this before in the last video, to go home. The distance is 2,100 meters, and the time to drive that distance is 15 minutes. Okay, that's pretty slow, but that's what we're given. After 11 minutes, how far are you from your home? Now remember, I said we cannot use this. So since the distance is linear, we need to first find the overall speed. And how do we do that? Well, we divide 2,100 meters by 15 minutes, as you will see subsequently. Since it requires 15 minutes to drive 2,100 meters, then in 1 minute, the distance traveled will be 2,100 meters divided by 50 minutes, which would be 140 meters per minute. That's not very fast, but that's what we have in this question. So we find the rate, which is like the gradient, except it's negative gradient. In 11 minutes, the distance traveled will be 140 meters per minute times 11 minutes, which would be 1,540 meters. But remember, the distance you started out with was 2,100 meters. So the distance remaining to reach home will be 2,100 meters minus 1,540 meters, which would give us 560 meters. And that brings us to the end of objective 21. Solve problems involving direct variation and inverse variation. And in objective 20, we actually looked at these two expressions here. Something is missing. So this brings us to the end of section 6, algebra. We have just completed section 6, algebra. Many learners have problems with this section, algebra. I hope that this has helped you if you are or were one such person. Objective 21, section 6, solve problems involving direct variation and inverse variation. This brings us to the end of video 22 based on objective 21 in section 6, and also that was the last objective in section 6.